To begin, 1 point requires clarity. 9.4 billion pounds. This magnitude is difficult to visualize. It exceeds any sum most individuals will ever encounter. It is the sum the UK government has allocated to carbon capture and storage, or CCS for short. The government has directed UK taxpayers' funds toward industrial emissions capture. Officials argue the funding will support the competitiveness of UK industry. It will create employment. It will reduce local air pollutants. It is an ambitious plan by any standard. The strategy centers on two large projects. Acorn, Viking. The core concept is to capture carbon dioxide before it leaves industrial stacks, then transport it through large diameter pipelines, and finally, inject it deep beneath the North Sea. The concept may seem extreme, but it is a real engineering pathway. This is not hypothetical. This is the United Kingdom's official policy pathway. The target headline capacity is substantial. Capture and store up to 18 million tons of CO₂ each year, comparable to removing every car in London from the road. Twice. It is a colossal ambition, financed by UK public funds. Government communications present an optimistic outlook. Envision new pipelines crossing industrial regions, ports configured not for goods, but for exporting captured emissions. Energy security, a new industrial revolution. Keep UK steel plants operating. Keep UK chemical plants operating. Keep UK refineries operating. Advocates argue the alternative is deindustrialization and greater import dependence on countries such as China. As of the 23rd of October 2025, this is the plan under review. So, why is this happening now? Why the sudden rush to build an extraordinarily complex plumbing system? Certain industries are inherently emissions intensive. Steel production cannot be fully decarbonized with electricity alone. Cement manufacturing cannot avoid processed CO₂ from clinker chemistry. Several chemical processes unavoidably release CO₂. That is dictated by the underlying chemistry. A rooftop turbine won't forge girders. Heavy industry needs high-temperature process solutions. These heavy industries underpin advanced economies. For such sectors, CCS is one of the few viable routes to deep cuts without shutting facilities. It is a lifeline. The strategy is to leverage existing assets. For decades, the UK has extracted oil and gas from the North Sea. A dense network of pipelines spans the seabed. Large gas terminals exist, most notably the St. Fergus gas terminal. The UK has a skilled workforce of engineers, welders, and divers used to extreme conditions. The concept is to run that equipment and know-how in reverse. Instead of extracting, the plan is to inject CO₂ back beneath the seabed. Legacy fossil fuel infrastructure becomes a large-scale CO₂ disposal system. This is not only about emissions, it is also about employment. Regions such as Aberdeenshire and the Humber built modern economies on oil and gas. As hydrocarbons decline, what happens to the workforce and to those towns? The objective is a new mission. Use CCS to sustain high-wage, high-skilled jobs in these communities. It is a transition, not a cliff edge. Those skills remain needed, applied to new roles in capture, transport, and storage. This is not a few pipes, it is the creation of a new industry, a motorway for carbon dioxide. It requires high-tech injection wells and continuous monitoring of underwater storage to prevent leaks. There is a real sense of urgency around this. The government is not merely discussing it, it is allocating funds to accelerate delivery. Officials argue that waiting would allow other countries to move first, and delays could prompt domestic industries to relocate to clearer jurisdictions. Accordingly, aggressive deadlines have been set. Officials state that ground could be broken within 24 months, rapid by infrastructure standards. If final approvals are secured, major construction could begin quickly. This is not a distant aspirational concept. Early-stage activity is already underway. Investors are monitoring closely. Large capital dislikes uncertainty. The £9.4 billion in public funding is intended as a market signal. It communicates governmental commitment to the program. Public capital is being positioned to de-risk private participation. The expectation is that private finance will follow. The model relies on companies contributing substantially more capital. Officials aim for their stake to unlock roughly £25 billion from the private sector by 2035. That leverage effect is the core objective. Timing also intersects with electoral cycles. The incumbent administration seeks final investment decisions before the next election. Securing FIDs would allow it to claim progress on industrial policy. Consequently, pressure on developers, Acorn and Viking, is intense. Engineering, cost estimates, and permitting must be highly robust. Delays or errors could cascade through the program. It is a high-wire act, with billions and thousands of jobs in balance. First up, Acorn. This is the Scottish contender. Its base of operations is the St. Fergus gas terminal in Aberdeenshire. This site has been at the heart of the UK's gas supply for decades. It is a large industrial complex, pipes, valves, tanks. The plan is to give it a new lease on life. The government has already allocated about £200 million to the development phase. That is seed funding to complete detailed engineering and planning. Acorn is seen as one of the most advanced CCS projects in the UK, ready to proceed relatively quickly. The core efficiency in Acorn is the reuse of existing gas pipelines. There are pipes already on the North Sea floor that previously brought gas ashore. Those pipelines would be repurposed to transport CO2 seaward in the opposite direction. This is a significant cost saver. It is akin to buying a used car rather than a brand new one. It remains expensive, but it avoids the monumental task of building everything from scratch. The plan is to inject CO2 offshore into depleted gas fields deep beneath the seabed. Acorn is not only about storage, though, it is also about fuel. There is a linked project called Acorn Hydrogen. The concept is to produce so-called blue hydrogen. Natural gas from the North Sea is reformed into hydrogen and CO2. The CO2 is captured and transported offshore via the main Acorn system. The hydrogen can then be used as a low-carbon fuel for power stations, factories, and heavy trucks. It is a way of using UK gas reserves without the full climate impact. It is a coherent, integrated plan. Every politician talks about jobs. Acorn's promoters estimate around 15,000 jobs at peak construction. That would be a major boost for the northeast of Scotland. Work spans welders, engineers, pipe fitters, and support staff. It signals continued prosperity for a region that has relied on oil and gas for 50 years. Acorn is positioned as the natural next step for Scotland's energy industry. Now attention turns south to England's industrial engine room. This is the Humber region, home to the Viking project. If Acorn is about clever reuse, Viking is about sheer scale. The Humber is the United Kingdom's largest industrial cluster. Refineries, chemical plants, power stations, emitting substantial volumes of CO2. Viking aims to be the solution for all of them. Its ambition is to capture about 10 million tons of CO2 per year by 2030. That would be more than half of the UK's total target from a single project. Viking's plan is to build capture facilities adjacent to major emitters around Immingham. A new onshore pipeline network would aggregate the captured CO2. From a central hub, a new offshore pipeline would transport the CO2 into the southern North Sea. There, it would be injected into a depleted gas field known as Viking. The project is led by Harbour Energy, a major North Sea operator with relevant experience and capital. Job estimates for Viking exceed Acorn's, with around 20,000 roles at peak construction. The plan emphasizes apprenticeships and training to build a new skilled workforce for this industry. For a region that has experienced industrial decline, it is a powerful promise. The vision is a modern industrial hub that is also cleaner. Both Acorn and Viking are now racing to reach a final investment decision, an FID, with all technical, financial, and regulatory pieces aligned. The United Kingdom is not alone in pursuing carbon capture and storage. There is a global race to deploy CCS at industrial scale. Reviewing peer initiatives helps place the UK's £9.4 billion commitment in context. Norway offers a prominent example. Its flagship project is Northern Lights, led by Equinor, Shell, and Total Energies. The model differs: a ship-based CO2 terminal and an offshore storage site. The service is marketed to emitters across Europe. In effect, Northern Lights sells CO2 transport and disposal. Factories in Germany or Belgium capture CO2, liquefy it, and load it onto specialized vessels. The ships sail to Norway, the CO2 is offloaded, and then piped to subsea storage. Initial capacity is about 1.5 million tons of CO2 per year, smaller than UK ambitions. That is a fraction of what Viking alone targets. Norway is sequencing growth cautiously, building demand step by step. The UK favors a larger, faster build-out. Across the Atlantic, Canada provides another benchmark. The Pathways Alliance is a major undertaking. It is a coalition of oil sands producers. Oil sands operations are highly carbon-intensive. Plans include a roughly 400-kilometer pipeline to a central storage hub near Cold Lake, Alberta. Stated goal: capture 22 million tons of CO2 per year by 2030, at an estimated cost of about $16.5 billion US. By comparison, the UK's $9.4 billion appears proportionate. The common thread is clear. Major energy producers view CCS as a necessary pillar. The UK approach is distinctive in linking CCS to regional industrial renewal, Humber and Aberdeenshire, and to legacy North Sea infrastructure. If this succeeds, and that is a substantial contingency, the potential rewards are significant. Let us define what success would entail. First, the climate dimension. If Acorn and Viking meet their targets, the UK could substantially reduce emissions from UK heavy industries, on the order of a 10 to 15% reduction in industrial emissions. It would demonstrate that heavy industry can be retained while meeting climate targets, a material proof point. Second, the financing. Public funds, $9.4 billion as initial capital. Primary aim: signal credibility and create investor confidence. Such confidence is intended to catalyze private capital, potentially unlocking $25+ billion in investment by 2035. Capital would flow into construction, engineering, manufacturing, and enabling technologies. This investment could revitalize regional economies, creating a virtuous cycle. Greater build-out lowers unit costs, attracting additional industrial participants. And employment impacts. Estimates suggest over 50,000 long-term roles once the network operates, extending beyond temporary construction work. These would include skilled, well-paid roles, operating capture plants, managing pipelines, monitoring storage sites, with pathways to retrain oil and gas workers for a low-carbon economy. Ports and terminals could become clean energy hubs. There is also an export opportunity. If executed well, the UK could develop world-leading expertise and technologies for Europe, the Middle East, and Asia. UK firms could design and build CCS projects abroad. The UK might, akin to Norway, store other countries' CO2 for a fee. The North Sea could shift from oil barrel to Europe's carbon sink. It is a bold, ambitious vision. However, alongside that vision sits a credible downside scenario. In that case, the $9.4 billion becomes a down payment on persistent cost escalation. Historical precedents include large, government-backed technology projects that ended with overruns and substantial public liabilities. A primary risk is cost overrun. Systems of this scale are vulnerable to delays and unforeseen technical complications. With elevated inflation, a project scoped at £1 billion can trend toward $2 billion. The allocation of overrun risk becomes pivotal. There is also the question of long-term funding. Beyond initial capital, who pays to operate the system over multiple decades? Will participating industries pay tariffs that fully cover lifecycle costs, or will ongoing public subsidy be required? If carbon prices do not remain sufficiently high or predictable, firms have limited financial incentive to procure CCS services. Adoption would then depend on regulatory mandates or continued fiscal support. That dynamic creates dependency on durable policy frameworks, an uncertain basis for a multi-billion-pound sector. Comparable challenges have emerged elsewhere. Australia's Gorgon LNG CCS experienced technical issues, delays, and prolonged underperformance against capture targets. Costs rose materially while captured volumes fell short. Critics also highlight social license risks. Communities may oppose high-pressure CO2 pipelines near farmland or towns. Securing planning consent for linear infrastructure can be protracted. Organized opposition can introduce multi-year delays, increasing costs and deterring investors. The stakes are non-trivial. The government is committing public funds on the expectation these hurdles can be overcome. It may prove judicious or imprudent. Beyond finance and policy, the enterprise poses substantial engineering complexity. It is akin to keyhole surgery on a nation-scale patient. All subsystems must operate reliably for decades. First, capture. Chemical solvents are used to scrub CO2 from flue gases. This applies to power station exhausts and to industrial stacks. Capture is energy-intensive. Excessive energy penalties can erode net emission reductions. The balance is delicate. Next, transport. Compress the CO2 into a liquid or into a dense, supercritical fluid, then pump it through pipelines at very high pressure. Pipelines must be incredibly robust. A leak wouldn't just be bad for the climate. A large, sudden release could be dangerous. It displaces oxygen. Safety standards have to be impeccable. Build a network that handles CO2 from many sources, all flowing to the correct storage site. It's a logistical nightmare. Final step, storage. Pump CO2 deep underground into porous rock formations, old oil and gas reservoirs, capped by an impermeable seal rock. The cap must hold. CO2 must remain trapped for thousands of years. That demands extensive pre-injection geological surveys and continuous monitoring thereafter. Use sensors to detect microseismic activity. Inspect the seabed for any signs of leakage. It's a permanent stewardship job. The system's performance is the ultimate question. If a project promises to capture 10 million tons a year, it must do that. Not 9 million, not 7 million. The finances rest on those volumes. If capture plants underperform, or pipelines and injection wells require extra maintenance, the whole business case can fall apart. The effort is akin to walking a technical tightrope, thousands of feet in the air, with 9.4 billion pounds at stake. Failure carries material risk. So, where does that leave the effort? The UK has committed significant public funding. The 9.4 billion pounds on the table is a serious statement of intent. The plan is to build a world-leading carbon capture industry on the bones of old oil and gas infrastructure. Acorn in Scotland, Viking in the Humber. They promise to capture up to 18 million tons of CO2 a year, create tens of thousands of jobs, and secure the future of heavy industries. It is, without a doubt, one of the most ambitious industrial projects this country has seen in a generation. Success would be transformative. It would give the industrial heartlands a new lease of life. It would mean a just transition for oil and gas workers into the clean energy economy of the future. It would position the UK as a genuine world leader in a vital new technology, exporting skills around the globe. It would demonstrate that industry can coexist with a clean environment. It is the optimistic, forward-looking vision of a country that still knows how to build big things. That is the prize. But failure would be a catastrophe. It would mean billions of pounds of taxpayer money wasted on half-finished pipelines and underperforming plants. It would be another grand British project that promised the world and delivered a mess. It would damage public trust in big infrastructure and set back climate goals. It would leave industries in an even worse position, having bet on a horse that fell at the first fence. It would be a story of overpromising, under-delivering, and leaving the taxpayer to pick up the tab. That is the risk. This is nation-building for the 21st century. It's a test of engineering prowess, political will, and financial nerve. The coming months will be critical. As Acorn and Viking push for final investment decisions, the question is whether the world's biggest companies are willing to commit their own money alongside public funds. The numbers are clear, the ambitions are huge, and the risks are stark. It's a high-stakes game, and the whole country has a seat at the table. One simple question remains. Will this £9.4 billion bet rebuild British industry for a new age, or will it be the most expensive way yet to burn through cash?